All right, we're going to talk about job control. This is one of those things that was introduced with Unix. I don't think it's really heavily available on other systems, but Unix being the world's most common model for building an operating system, we have it in Linux, which exactly copies the way Unix handles this. And the other really common operating systems like Minix, which is a sort of Unix clone, also have this kind of a capability built into it. So for being able to do this, you're going to have to be able to either be on a Macintosh or use the virtual machine that you built in the previous lecture where you loaded Ubuntu and run this at the Ubuntu console. It works sort of like this if you use the Linux subsystem in Windows, if you have access to that. But it doesn't really work like this completely if you're just using a bash shell on Windows. Windows has a different process model that doesn't have all of these features. So a little overview about what we're going to be talking about in this lecture. We're going to start out with job control and how we manipulate foreground and background processes, listing existing processes, how to kill a process or to control it. And then we're going to move on to other process things and eventually get to remote system access, which is a different kind of application running processes. So, job control. Now, when you just run a command at the Linux prompt, let's just do something like ls, what it actually does is the shell goes out, and this is the Unix way of starting commands. Now, why this is, I will explain. But it creates this new process by forking a copy of the shell itself. And so now there's two copies of the shell, and then one of them becomes the parent, and the other one becomes the child. The child process then replaces itself by loading the ls command and saying, okay, I am now the ls command. This is the fork and process. Now, the parent knows that it's the parent. It has a little flag that says this. And when it knows that it's the parent, it says, oh, am I supposed to wait for this child process to complete, or do I just continue? And the default is to wait. So if you have some process, and we're going to run something that's slow so I can demonstrate this, but if I run some process that takes some time, then it sits there and waits. So let's do a program called sleep. All it does is just wait for an amount of time. And let's say it does 5 seconds. Now, it's sitting there waiting for that child process to complete. It doesn't have to wait, but after 5 seconds, it finishes and you get back to prompt. So if we build a program that waits a long time, I can say wait 10 seconds, then it's going to wait even longer for it to finish. Lots and lots of times you want to run something, but you don't want to wait. You're tired by this point of waiting for it to complete, and you'd like to move on to the next thing. Now, remember that this is an entire separate process, so the shell is intentionally waiting for it to complete. Certainly, when you go in your Windows shell or the desktop finder in Mac, and you double-click on something, you don't expect the desktop finder to sit there and just wait until that thing that you ran completed. I mean, you kind of expect it to just go on to the next thing. And you can get that kind of behavior out of the command line shell like this. If you put an ampersand sign at the end of the command, it says, don't run this in the foreground, just let it run in the background. And you'll notice that it says 1 and this number. That number is a process ID number. And at this point, you got back a prompt. Now, if you sit here and just wait long enough, eventually it'll say, oh, done. The sleep completed, and it saw that, and it told you, oh, by the way, your background process finished. Now, if you have a background process that's producing lots of output, this usually is quite annoying to stop or have it run in the background and go to your terminal. But remember, in Unix, it's trivial to pipe things to a file. So if you have a process producing output, you can just say, oh, and take all the output and send it off to a file. I don't need to see it until later. And for instance, if I do find, which is a command that finds files, and I do tilde, which is my home directory, and say that I want to in my Go source, we'll give it some reasonable thing here. So I'm going to go look in this directory for stuff, and I want to find all of the stuff, okay, that starts with Go or ends with Go, has a Go suffix. Now, if I just go and run that thing, okay, it's producing all this output, but it takes a while to go and search that. Not a huge amount of time, but it produced a little list, and it took a few seconds. If I want that to go to some file name, let's say I just want a temporary file of $A, it sits there and it produces it. It sends it to a file. But let's say that I don't want to wait for it to finish. And there's lots of reasons why you might not want to wait for it to finish, because it's going to take time. So I could say, I really want that in the background. And when it gets done, it'll tell me it's done. Now I have the list of all of those files that it found, but that list is in a file so that I don't have to, I can edit it, I can search it, I can do other things with that file. Now, by default, there are two different files that get written to by programs in Unix. One of them is standard output. That gets piped with this single output, and there's another one called standard error. And this particular program didn't have any errors, but sometimes you have programs that are producing errors that you may want to ignore, or you're looking for the errors themselves, and you can send them to different files. So you can run something in the background and capture the output, and you don't have to see it on your terminal. Now, if you do something that is slow, let's say sleep, we'll sleep for a half a minute, and you run it in the background, you can also find out what processes your terminal has run in the background. You can use PS to get a list of processes. That'll be all the stuff that you personally have created on the system. And you notice I've got a big long list. Or you can use jobs, which is built into the shell, which says, oh, this is the set of jobs that this particular shell has created and run. And it says that you're running 1, which is sleep. It actually finished. Let me run 2.